Hello everybody, and welcome to another series of videos from scriptingisfun.com. In this series we're going to build an Asteroids game, just like the old classic Asteroids game from days gone by. So what I've done here is I've set up a brand new project in Unity. So if you're not sure how to set that up, you go to File, New Project, and then you go, we set it for 2D. You don't need to enable analytics at all, and then you just give it a name. In this case I gave it the name Asteroids, but you're free to name yours whatever you like, and then you just hit Create Project. Now I've already done this, so I'm not going to do it again, but what will happen then is it'll pop up just like I have it here. Alright, so in our empty project, the first thing we need to do is gather some assets here. We're going to need some asteroids, we're going to need a spaceship of some sort, and some other miscellaneous things. So I've gone out and located a few free assets online, and I'll put the links down in the description to where you can find these assets, and then you can use them as well. I've got a spaceship here. I'm just going to drag it into my assets panel here from my desktop. So I've got the spaceship right here. And this is from a site called Millionth Vector, and I will of course put that in the description below. There's a whole bunch of different spaceships you can choose from. Alright, so I'm going to bring some asteroids in. Alright, so here's the asteroids, and we'll just drag this over a little bit so we can see them. So we have different ones here. We have some gray ones, we have these reddish ones. There's 3 different varieties, I believe. And quite a few to work with here. We've got large versions, we've got medium versions, and small versions of all of these, so that'll work out well. So we can use these to pick from, and there's quite a few. Alright, so let's start by doing a few things with our player and getting our camera and project set up. Right now with our camera, we just have a default blue background. Let's change that background to black because they're going to be out in space. So I'm just going to click in the background color bar and drag that down to black. And now we have a black background. And let's go ahead and drag that spaceship out here into our scene just to see how big it is compared to everything else. So there it is, the spaceship. And let's take a look back at our camera here. So let's set our camera space using our spaceship kind of as a representation of our scale. So in a 2D camera like we have here, it's in the orthographic projection, that's what makes it 2D, and size is kind of our zoom, how close to the action we want to be. You also in a 2D camera want to make sure you keep your camera at 0Y and 0X, so that's right in the center of the screen, and then we pull it back from what it's looking at a little bit, so -10 on the Z to pull it back. And then let's just kind of drag the size larger. So as we go larger, you'll notice in the scene view down here that as I drag this larger, the box on the screen gets bigger. That's the amount of space my camera can see. So let's get out here a little ways. Maybe we'll go around to 10. Let's try that. And this is just kind of trial and error to kind of get a feel, because this is how much space we're going to have to play with on our screen. Okay, so now I've got our camera set for now. We have our background color set, we have our spaceship in here. So let's start working on the spaceship. In the original Asteroids game, the spaceship would move around in any direction, and we had screen wrapping where if the spaceship went off one side, it came in on the other side. So we'll go ahead and replicate that in our version as well. So we're going to need to add a few things to our spaceship. We're going to be moving our spaceship using a rigid body, using the built-in physics, Unity physics for this. So we're going to want to make sure that we add a rigid body component to our spaceship. So here's my spaceship. I'm going to add component, physics 2D, because we're working in a 2D game, and we'll get a rigid body 2D. Now we want to make sure that our gravity scale here is set to 0, because there is no gravity in our space here. And if we had that set to a positive value, it would fall off the bottom of the screen. Everything else for now can be left alone. We're just going to make sure it's got the rigid body and that gravity scale is 0. Alright, so now we can go ahead and make a script for our spaceship that'll handle player controls and movement. and things like that. So let's go make a new folder over here just to keep organized. So I'm going to create a folder. We'll call this scripts. And then in the scripts folder, let's create a C# script, and we're going to call this Spaceship Controls. Alright, Spaceship Controls we'll call it. And then we'll double click that to open it up in MonoDevelop. Here's our new script, Spaceship Controls, open in MonoDevelop. And the first thing we want to do is get some input from the keyboard. We're going to use the arrow keys, or the WASD keys, for thrusting. And really in this game you only need forward thrust and left and right rotation. So we won't be using the back keys at all. So we're going to go into Unity here real quick, into the input manager, and set up those controls. So to get to the input manager, you go to Edit, Project Settings, Input. That gets me into the input manager. We have some pre-built inputs for keyboard and mouse. This first one, horizontal, is for key or mouse button, and it's set to the left and the right buttons and the A and the D keys. So this is normally used for side to side or horizontal movement. We're actually going to use this for rotation, and so the left rotating in a negative direction will be just fine, because the negative rotation does actually rotate to the left. And the positive button right, these are the arrow keys, and then the A and the D key, we'll go ahead and leave those as well. Everything else we can just leave the same. So this one's already good to go. The other one we're going to use is vertical. Vertical is the default one that's set up to use the up and down arrows and the S and the W key. Now in our game we don't want to be able to move backwards. We're only going to be able to thrust forward. So we're going to take the negative button, the down button here, and we're just going to delete it. So I'm just removing from negative button and the alternate negative button. So this input now will only work with the up key or the W key for forward thrust. Everything else can be left the same. So our inputs as of right now are all set up for movement. We'll talk about firing bullets and things like that at a different time. So here's our input setup. So now if we go back to our script, we can start scripting this in, where we can get some movement going. So keyboard input has to be looked for every frame that your game is running. So in our update function here, this is our game loop, we're going to put in here the code that's going to check to see if the key is pressed, and if that key is being pressed, then we're going to apply some forces with our rigid body. So we're going to need a few variables here, so let's put those up here at the top. We're going to need a link to the rigid body of our chip here so we can apply some forces to it. So let's make that a public rigid body 2D, and we'll just call that RB for rigid body. And then making it public will expose it in the inspector, and we can go out there and assign it there. So that's going to be for our rigid body. Okay, then we're going to need a public float for the amount of thrust that we have. So how hard do our little rockets push us when we want to add thrust? So we're going to have a float for that. We'll also have a public float for our rotation speed, so our rotational thrust. So we'll call this our turn thrust. So if when we turn left or right, we have little rockets that are going to do that. They're going to rotate us. So how hard do we push? How fast can we turn? All right, so we need those two variables for now, for sure, to control our ship. Okay, so now when we'll set these out in the inspector, and we're going to work in the update function here, where we're checking every frame. We're going to get input from the keyboard and apply thrust. Alright, so we got to add a couple more variables here. So we're also going to need a place to store our input. So let's make, these don't have to be public, these can be private. And so private float, this is going to be thrust input. And then we want a private float, and this will be called our turn input. Okay, then in our update function is where we're going to check for key presses. So check for input from the keyboard. And we want to do this here because, whoops, it's not in out, it's input. We want to do this here because update runs every frame. So this will get us the most constant checking for input that we can get, as fast as the computer's drawing frames. We want to know as soon as that key is pressed, that it's been pressed. And we're going to store that in these private floats we made. So thrust input is going to be for our forward thrust. So we need to get from the input system, so input, get axis, and the axis we want is the vertical one. That's for our up arrow. And so we're going to get from the input system, we're going to tell, hey, get the axis that's set up as vertical. This is going to return a value between a 1 and a 0, or a -1 and a +1 actually, but we've made it so it's only looking for positive values here in the input system. So this is going to get us between a 0 and a 1, and if it's 0 we're sitting still, and if it's above 0 we're going to be moving forward up the full amount of thrust, which would be 1. So that's going to get checked every frame, and if there's any input coming off of here, it'll get set to whatever that current value is. And then we're also going to do the same for our turn input. So our turn input, same thing. We're going to go to the input system, and we're going to get an axis. And this time the axis that we're going to want is our horizontal. Horizontal axis is the one we set up to work with our left, right arrow and the A and the D key. So this will return a value between a -1 and a +1, depending on if we're on a negative key or a positive key or no keys at all. So that's going to get our input. Then to actually apply the input and actually start moving, we need a different function here. And this one is going to be called fixed update. Has to be spelled exactly the same way here as I've spelled it. This is a known function for Unity, and the fixed update function is like the update function. It is constantly running, but this one runs on a fixed time interval. So for the physics system in here, if we move it on the fixed update, that just works better. You get more accurate results running physics things in the fixed update. So if you're applying forces, you generally want to do it here. So what we're going to do now is we're going to go to our rigid body. That was the RB variable that we made. And we're going to say to the rigid body of our spaceship, let's add some relative force. Add relative force will add force along the local axis of our ship. So no matter which way he's pointing, for instance, it'll always move him towards where he's pointing at. So we're going to add a relative force. We have to tell it what the vector we want to apply the force is. So we're going to say vector 2, because we're working in a 2D system here, and we're going to say dot up. Vector 2 dot up is a vector that has a 0 in the X spot and a 1 in the Y spot. So basically we're telling it apply force only on the Y axis. Now our spaceship, if we go out and look, is drawn so that he is pointing, let's get the arrows here, this green arrow here is the y-axis, so he is pointing along the y-axis in a positive direction. So if I apply force, a positive force on the y direction on him, he'll move this way, which is his way he's pointing. So that's why we're writing it like that. Okay, so it's vector 2 up. Now that's only going to put a 1 there, so we want to have some more control over how fast we can go. So let's take this times our thrust. That's going to be a float number that we're going to use to control how fast we're moving. Right now, since we haven't initialized it with anything, it'd be a 0, so we'd just be zeroing out our thrust right now, our movement. Made a little mistake here. Alright, so in the fixed update, we're going to take the vector 2 up, and we're going to take this times our thrust input. This is how we get control over our thrust from our input. So the thrust input is getting fed by our up arrow, so if we're not holding it, that'll be a 0, which will zero this out, and we won't have any thrust. If I'm holding it, I'll get some forward thrust. Okay, So let's save this. Let's go out into Unity. Okay, now that we've got the script ready to test out the thrust, we'll go over here and we'll attach it to our spaceship. So on our spaceship, we haven't put the script on there yet. Let's drag it over here and drop it. We have to hook up a few things here. We have to tell it which rigid body we're talking about. Right now it says none. The one we're talking about is the one on our spaceship. It's this guy right here. So if I click and drag on the rigid body 2D word there, I can drag that down and drop it in. So now I have told the script that yes, the rigid body on the same object you're attached to. And then we got to give it some thrust. So when I'm pushing the key down, how hard do I want it to push? Let's just start with a 1 and see what happens. Alright, so if I hit play now, I should just sit still. Okay, I'm sitting still. If I push my up arrow, I get a little thrust. So I just pushed it for maybe a second and let go. I got some forward thrust. Now, we are simulating a space type of environment, so the way that add force works is that it will add a force via the physics system, and if I don't have any gravity or friction applied, it'll just keep moving forever along that same line of force. Okay, in the rigid body on the spaceship, you see we have something called linear drag. Right now that's set to 0. Think of that as the friction as you're moving forward. So in space there isn't really any drag, so we're going to set that to 0. Okay, so that's forward thrust. Let's take a look at our turning thrust. Okay, because now it'd be nice to be able to turn and move around a bit. So let's go back to our script. So we've got the input for turn right here. So what we're going to do is we're going to add some torque to our rigid body. So we're going to say rigid body, we're going to add torque. It's right here, this one here. And the torque something means to spin it. So we're going to add some torque. We have to tell it a float number amount of torque to add. Alright, in a 2D game here, it's going to automatically add that torque along the z-axis, which is the one that's going through our object from where we're sitting looking at the screen. So it's going to do that automatically for us, and the amount we want is our turn input. So based on our turn input, we're going to add some torque. So let's see what happens if we save this and test this out now. Go back out to Unity. We'll go here to our turn thrust. So now we got to give ourselves some turn thrust. Let's give ourselves maybe a 5 and just see what it does. And when I hit play here, let's go ahead and zoom in on my ship here in the scene view as well. When I hit play now, if I go to the left, it starts spinning. Okay, so when I went left, it actually spun it to the right. So that means we've got to invert this. You'll notice that it's very slowly starting to slow down. If I hit the other key, it'll overcome that momentum and start flipping me the other way. But you see I'm turning in space right around the center point of my ship. And I can control that back and forth. So we need to invert those controls, because in mine at least, when I go left I'm turning right. So a way that you can do that would be just go ahead and put a negative sign here in front of turn input, and then it'll just reverse the direction for us. So we'll do that. So if yours was turning opposite your keys, just put a minus sign there and that'll flip it around. So now if I hit play and I push on the left arrow, I start turning left. And again, the longer I hold it down, I'm just going to hold it down for a bit, the faster and the faster I'm going to spin, because I'm just constantly adding that force, and it's just going to get faster and faster. To overcome that force, I have to push the other way, so I'm pushing on the right arrow now to try to combat that, and at some point I'll stop moving. Okay, so now if I can kind of kill my rotation, if I push forward, you'll notice I'm moving forward in the direction that I'm facing, and as I turn, I keep moving in the direction that I'm going. Now, I can already tell this is kind of a hard to control system here. It does sort of simulate how space works, how those forces just need to be counteracted on. So for the moving forward, the thrust, I'm going to keep that, but for the rotation, I want to be able to turn relatively quickly, probably about like what I am here, but I'm going to want to have a little more dampening on that so that it doesn't just keep rotating. So we'll kind of pretend like the computer is assisting us here as we're piloting our spaceship and helping us with our turning. So let's try turning our angular drag up to something like maybe a 0.1. The more you add here, the more drag you have, and it's going to damp our turning. So let's just see what that's like. If I get turning a bit now and I let go, see, it's still taking a while to stop, but it should slowly stop. So a 0.1 probably isn't enough. Let's try going all the way up to a 1. We can go higher if we need to as well, but we'll just kind of experiment here. So at a 1, I slow down a little bit faster. So I'm pressing the key now, I just let go, and there. So maybe we'll try that for now. So as I'm moving, if I want to go the other way, I've got to kind of spin around, and I've got to kind of anticipate when to stop holding the spin key so that I get the right amount of spin. But now I'm able to turn around and spin, and yeah, that's not too bad. We can try that. Now, of course, if we add more turn thrust, we'll turn faster. Let's just see what that does. Make it a 10 instead. So I can turn a little quicker, but I am adding more spin, which means it takes longer to correct. Okay, so that's just one possible way that we can do controls here, where we're using the physics system to move us around. Okay, we'll leave it at that for now. We could look at another way to turn here later if we decide that this is a little unwieldy. Alright, so next thing we want to do is work on the screen edges. Right now, if I go out past the edge of the screen, I just keep going off screen. So we want to actually have screen wrapping in effect, where basically if my guy flies off the edge here, he actually just comes back in the opposite side. So we just want to flip him around. So we're going to do some basic screen wrapping here. And the key to screen wrapping is figuring out the points on the edge of our screen here where we can no longer see our spaceship. So for going up, if I look in my scene view here or up in my game view, as I drag it up, right about here, we're outside the view of the camera. See how I'm just past the white line here and I can't see myself up here? So I can look at that coordinate in my inspector and see that that's at a 10.89. So we'll just maybe call it an 11. Alright, so we'll set that to an 11, and that brings us a little bit further off the edge, but I don't think it's going to be that big of a deal. And sometimes working with a nice round number is easy. We could always adjust that if we need to later. So now, if it's at an 11 at the top, and if this camera is in the exact center of its view, which it is, then we know that if we made this a negative 11, that our ship will pop down here to the other side. So if I put a negative sign here, see how the ship popped down here off the bottom here? So that's basically what we're going to be doing here. We're going to be checking every frame to see if our ship has gotten out of view of the camera. So basically, has it gotten past that positive 11? If it has, then we're going to change its position on the Y to a negative 11, which will pop it right down to the bottom. So your numbers might be a little different than mine if you made your camera a different size. My camera is size 10 right now, so that put my my boundaries out here at the 11. So you may have to experiment to get the numbers that work for you. But let's go ahead and implement the wrapping here for our y-axis. Now we're going to do that in the update function because we want to check every frame to see if it's time to move. Okay, so we're going to do here, we're going to do our screen wrapping, and basically we're just checking coordinates. So we want to find out where we are currently on the Y and see if that's outside where we can see. So we're going to say if transform dot position dot Y. So basically I'm saying go into the transform of my spaceship, look at its position, and get the Y float value out of that. Now if that is greater than, because as we go up the screen Y gets bigger, if that's greater than 11, then we want to do something. Now one thing we probably want to do is avoid hard coding numbers in. So we're going to make some variables here that are going to hold the boundaries of our screen. So let's make a public float, and we'll call this screen top, and then we'll do a public float screen bottom. And let's go ahead and add in a public float screen left and public float screen right. Now we could just get by with 2 if we just kept the screen vertical and the screen horizontal and then just used minus signs, but we'll do this to kind of keep it easier for us. Alright, so we'll fill these out in the inspector with the numbers. So we'll put that 11 out in that variable for screen top. Okay, but if the transform position on the Y gets greater than our screen top, then we know that we are past that point where we want to switch. So what we're going to do here is we're actually going to move the position of our ship. So we have to build at a new vector 2 position and move it to that spot. All right, so we're going to do it here. New vector 2. We'll call this new position. We're going to set this equal to, now what we want it to do is we actually just want to set it to our current position right now. Then depending on if we're off the edges of the screen or not, we're going to apply it to our ship. So there's a couple of different ways we could do this. I'm just trying to combine a few things. So new position is going to equal transform dot position. So basically I'm just copying this in. Now I'm going to save this and see if it gives me any trouble with saving this, because transform position is actually a vector 3, so let's see if it'll let me save it into a vector 2. Let's check them for errors. Okay, it looks like it's not going to have a problem with that because I didn't get any errors here in the console. So let's go back in here. Alright, so we're setting up a new position, we're setting it in. Now if our transform the Y gets greater than the screen top, then we're going to want to modify this new position. This new position is the one that we're going to move to after we're done doing our checks. So we would say new position dot Y. So we're going to the Y component of new position, and we're going to set that equal to our screen bottom position. Okay, so screen top is where we can just barely see off the top. We're going to go now to the screen bottom. So we're going to set them to screen bottom, which is a float number, which will be where we want them to pop up to on the bottom. Alright, now we're going to kind of copy this if statement here, because we're going to have to check a few more sides, because we have 4 sides to the screen. So let's paste this in, and let's do the bottom. So on the bottom, we're going to ask if transform.position.y is less than, because remember as we go down the screen, y gets smaller. And now we're not checking screen top, we're checking for the bottom, So if our y is less than the screen bottom, we're going to set the vector, the new position y, not equal to the bottom, because that's where we already are. We're going to pop ourselves back up to the top. So screen top, like that. Okay, so this actually should now be ready to go, and then all we have to do here is apply our new position. So we'll just say transform dot position equals new position. Alright, so if neither of these were true, then we'll just set our position back to where our position already was, and we shouldn't notice anything. So we are setting the position every frame in this, the way I'm doing it here, but I don't think it'll cause any problems. So let's go in here and just kind of check it out. Alright, so in Unity here, before we can test it, we need to actually tell it where the screen top and bottom is. So we already determined the screen top was around an 11, and the screen bottom would be a -11. So we got to put those numbers in. That's very important. Otherwise, if we leave the zeros in here, it's just going to lock us into the middle of the screen. So now with those values plugged in for top and bottom, let's give ourselves a little thrust. Okay. So we are thrusting gently up the screen, and when I get to the top, I should pop around to the other side. And there we go. Now if I rotate around, and I start thrusting back down towards the bottom here, I should also loop from the bottom to the top, and there it goes. Alright, so that's screen wrapping on the top and the bottom. Now what we'll do is we'll go in and we'll do screen wrapping from the left and the right side. So again, same idea. We are just going to do 2 more checks, one for the left and one for the right side. So I can just actually copy these 2 if statements here, and let's just paste them in right here. And this time we're checking for X. So this time, in this one, if transform position X gets greater than the screen right, okay, bigger than the right side of the screen, then we'll change the X to go to the screen left. We want to go to the left side of the screen. And then in this last one here, if our X gets less than the left side of our screen, then we will change the X to the right side of our screen, like this. Okay, so this is checking for the top, moving to the bottom. This is checking for the bottom, moving us to the top. This is checking for the right edge of the screen, moving us to the left edge. This is checking for the left edge of the screen, moving us to the right side. Okay, and then after we've done all those checks, we just apply whatever changes. So if, for instance, we happen to hit the exact corner of the screen and we need to flip both X and Y at the same time, it'll do it right here. So let's save that and go back in, and we have to make sure we put in our screen left and screen right numbers. Now, this is where you want to double check your game view to make sure what you're in, what aspect ratio you're in. I'm in standalone. Sometimes it defaults to free aspect. You notice when I put it in free aspect, it changed the shape of my camera. Because in free aspect, whatever size my window is, that's the size of my camera. I don't want that. I need control here because I'm doing screen wrapping. Those edges can't move. So I'm going to be in standalone. So make sure you set that, because now if I make it smaller, you notice how it doesn't change down here. It keeps the same aspect ratio. So that's what we want. Okay. So here's screen left and screen right. We have to figure out where those spots are. So let's grab a hold of our spaceship and let's pull them over here till we can't see them off the right side. And it looks like it's going to be somewhere around a 14. So let's go ahead and make screen right a positive 14. And of course, screen left will be the negative of that. So because again, the camera's right in the center of the screen. So we'll make that a negative 14. So now we've got our screen edges dialed in, and if later we change the size of our screen or we change our aspect ratio, we just have to figure those numbers out again and just adjust them here, and it'll work just fine. So let's hit play, and I'm off the edge of the screen right now already. So let's just see if I can come back onto the screen. Alright, so here I am coming across the screen. And when I get to the other side here, I'm going to start turning so that I can thrust the other way. I should pop over here, right? And now I'm thrusting the other way to overcome my inertia, just like you would in space. And if I go this way, I'll come back over there. If I come up off the top in some weird angle like this, I'll pop back on the other side, coming up the bottom there. So there we go. We have our input controls. We have our screen wrapping. Our spaceship is ready to navigate and fly around the screen here. So that's the first chunk of our project. Getting our project set up and getting the spaceship in and getting some basic controls started. In the next section of our project, we will start working on our asteroids, getting an asteroid in here.